Okay, ladies and gentlemen, we're going to do Lab 29 this week. Our scenario this time is that we have some vanillin material. We are Pulp Incorporated, and we are a large paper company, and we make products from the byproducts of paper production. And if you treat a molecule from paper production called lignin, of course, it's a plant-based product, you get large quantities of vanillin, which is obviously the chemical responsible for the characteristic aroma of vanilla beans. So our development manager, Woody Aspen, has asked us to uh, develop a method to reduce vanillin to vanilla alcohol. And in that process, what we're wanting to do is we're going to uh, make a product that could possibly be used in order to create some products for some perfume industry or things like that, where we would use the vanilla alcohol uh, would be a component of a perfume or something. And then maybe the vanilla alcohol itself could be modified in some way. So what we're looking to do is, and you can see here, a lot of these parameters are given for you. The second aspect of this thing is, since we're here at the end of the semester, you're going to develop your own procedure for this. I'm going to give you some parameters, and you're going to need to email me back before Thursday, obviously, a procedure that you come up with. Of course, this is modern day and age, and when this book, first printing of this book, the proliferation of the internet was not as good. So my guess is you're probably going to be able to very easily find some procedures that will be legit. I'm going to give you some parameters. You're going to have to stay with them. And if you'll notice, this example I'm giving you from another university is showing you probably the chemicals you want to use. So anyway, what we're going to try to do is reduce, and reduction, quiz question here. Reduction is the process by which we either add hydrogens or remove oxygens from a molecule by using a reducing agent. The most famous and probably most popular reducing agent is lithium aluminum hydride. Here is lithium aluminum hydride. If you're looking at this screen right here, you can probably get some reasons why we're going to use a different reducing agent. Number one, we don't have any on the premises. And number two, you can probably see why. So what we're going to do is use a reducing agent called sodium borohydride. And sodium borohydride, you can see, is a molecule with lots of hydrogens in it. So we're going to convert this, in our case for reduction, we are going to add an H here and an H here to this molecule. And that's going to be our uh, reaction that we're going to perform. So let's get right to it. And you'll know, here are the notes that I have for this on what I want you to do. Obviously, I want you to attempt to produce vanilla alcohol to vanillin from a procedure that you devise. The only parameter I'm going to give you is you're going to start with 25 millimoles of vanillin. We're going to use sodium borohydride. Um, look on page 227 for the stoichiometry of the reaction. Uh, you'll need to calculate how much NaBH4 that you will need. You should then calculate in a 50 to 100% excess, since side reactions can occur. For the solvent of your reaction, you may use either sodium hydroxide or one of these three alcohols, methanol, ethanol, or 2-propanol. The reaction does not work well at a low pH. Typically, alcohols are not considered either strongly basic or acidic. Notice that sodium hydroxide is a very strong base. So pick your solvent accordingly. That's going to be your solvent. But it's also, besides being the solvent, it's going to be your initial source of hydrogen ions in the beginning, before you add the sodium borohydride. So The side groups, uh, the original OH and COOH. So you can see alcohol itself kind of gives a rapid decomposition of your reducing agent, your sodium borohydride. So obviously you can monitor during the reaction uh, if you're going to keep the pH above 10 if you decide to use NaOH. The problem with alcohols, but you can use them. I'll have alcohols available. It depends on the procedure you come up with or you locate. Methanol and ethanol are okay, uh, and you can get the reaction done in under 30 minutes. To propanol, you're going to have to go above a half hour. And the problem with it is it's harder to get out of there. And amounts of solvents to use are listed on top of page 228. You must keep the reaction under 25 degrees Celsius at all times. This is one of the few times we've had a reaction where we've had to monitor that. So be careful. You may have to have in your procedure, you may want to put in there something about having an ice bath or something available to keep the reaction down. There is a paragraph on the end of page 227 that will tell you the order to add the chemicals in. Time considerations are also discussed on page 227. Remember, we added an excess of NABH4 to make sure we have enough during the reaction. But if there was any left afterwards, we have to get rid of it. So you're going to have to put in some sort of a consideration on what you're going to do to get rid of the excess NABH4. Separation of the product will have to factor in. If it's a solid, you can use filtration. If it's a liquid, you'll have to use extraction. And if there's extra solid in the filtrate, you could extract it out of that if you want to. But as long as you get a decent amount of product, you're going to be okay. We're going to analyze the product by IR. We do have a device that can analyze solids on the IR, and we're also going to get the melting point. Probably going to want to let the material dry over the week and then get the melting point the following week. So that would give you 2 reports due the last night of class. Or if you want to just suck it dry a little extra because it's a fairly short reaction, you can probably get the thing dry enough that you could get a melting point that evening. Now that's up to you on that part. Because as you're doing the final experiment, which is not a long one at all, basically it's just going to be running materials through the UV machine. You're going to have plenty of time to do a melting point, although that does give you 2 reports for the final night. Now, you can recrystallize the solvent or the material if you want. If you read some procedures online, you'll see that a lot of people don't on this one, that just rinsing with some cold solvent, whatever solvent you decide to use at the end. The cold solvent seems to do a good enough job that most people do not recrystallize. But if you want extra purity, be my guest. Here are some information I will give you about recrystallization solvents. Vanilla alcohol is soluble in hot water, hot and cold ethanol, hot and cold ether, and hot benzene. It is insoluble in cold water and benzene. You might want to look up which one of those 2 chemicals would probably be the easiest to work with, and you can probably guess which one that is. So a lot of this is not brain surgery. If you just read through the procedure, you can see what's going on with it. So the reduction process, essentially what you're going to be doing through the process is you're going to be, I'm going to have to run this into a second one to finish this. So I'm going to go ahead and stop this one now, and we'll pick it up on the second one.